In this video, we're going to take a look at arc length. What is arc length? Arc length is the length along a circular path. It's part of a circumference. So let's remember that the circumference of a circle is 2 pi r. If I'm going to take a part of that circle in degrees, then it's going to be the entire circle times a fraction, whatever fraction of the circle you're talking about. The easiest way to get the fraction of a circle is to do whatever the angle is over 360 if you're in degrees. Today we're going to look at arc length in terms of radians. So part of the circumference of a circle using radians, it'd be 2 pi r times times theta over 2 pi. As you can see, the 2 pi's cancel, and you're left with S equals r theta. Now what is S? S is arc length. It's the part of the circumference of the circle, otherwise known as arc length. Theta must be in radians in order to use this equation. Let's take a look at an example. In this example, we have a child on a merry-go-round rotating along a circular path 60 degrees. So it only goes 60 degrees around the circle. If the merry-go-round has a diameter of 20 feet, what is the length of the child's path? In other words, what is the arc length? So here's 3 steps to solving word problems in math. You convert to units that you can use. You solve it using the formula, and then you convert again if the answer asks you for a specific unit. Right here we have the angle of 60 degrees, and we have a diameter of 20 feet, which can give us the radius. Remember, radius is half the diameter. So if the diameter is 20 feet, the radius is 10 feet. The angle is 60 degrees. Now, because it's 60 degrees, we have to convert to radians in order to use this equation, because this equation only works if your angle is in radians. So let's see how we convert this into radians. We put 360 at the bottom to cancel out the degrees. We put 2 pi on top because that's a full circle in radians, and we multiply straight across. That gives us 120 pi over 360. Those cancel out to give me pi over 3. Alright, so this pi over 3 is our new angle, so we just need to put it in the formula. S equals r theta. S is what we're looking for. R is 10. Theta is pi over 3. You multiply that straight across and you get 10.47 feet. Now I know we get 10 pi over 3, but usually we don't have lengths in terms of pi. It doesn't make much sense to us. So we just went ahead and multiplied and divided and got the decimal. Now let's take a look at area of a sector. It's the area of a section of a circle, so it's pretty much going to have the same premise as what we did with arc length. It's part of an area. So area of a circle is pi r squared, as you well know. So part of that would be pi r squared times the angle over the entire circle. This is in degrees. Let's see what it looks like in radians. In radians, we have pi r squared times theta over 2 pi. If we simplify this, we get r squared theta over 2. Now the area is A, and the theta must be in radians. Let's take a look at an example. What is the area of a slice of a 10-inch Chicago style deep dish pizza if it is cut into 8 slices? Well, the 10-inch diameter, just like in the first example, helps us to get our radius, and the fact that it's cut into 8 slices will help us get our angle. Alright, so first of all, we know that R is going to be equal to 5 because R is half the diameter. Now theta, on the other hand, if a pizza is cut into 8 equal slices, we're assuming the 8 slices are equal, theta is going to be equal to the whole pizza pie, see what I did there, divided by 8. Now if we simplify this, 2 pi over 8 becomes pi over 4. Because 2 into 2 goes 1, 2 into 8 goes 4, you get pi over 4. So now my area is going to be equal to 5 squared times pi over 4 divided by 2. Now we can plug this all in the calculator and see what we get. We get 9.82 inches squared. And that's it, folks.